Welcome back. In today's lesson, we will be looking at absolute value equations and absolute value inequalities. So, what do we already know about absolute value? The symbol that you see here, the two straight lines on either side of the 8, may look familiar to you. You've probably seen this before. This question is asking, what is the absolute value of 8? And it is 8. In the next question, what is the absolute value of negative 3? It's positive 3. So one thing that you may remember about absolute value is that the answer, the result, is always positive. So the absolute value of a positive number is positive. The absolute value of a negative number is also positive. It doesn't change the sign of whatever was inside of that symbol. It just makes the result always positive. So the reason it's always positive is because absolute value measures the distance that the number is away from 0 on the number line. And so anytime in math when we are talking about a distance is always going to be a positive measure. So in thinking about solving absolute value equations, we're going to start with a very simple equation. It is that the absolute value of x is equal to 4. Anytime we're solving an equation, we're trying to find what is the value of x that makes the equation true. So in this case, one possible answer could be 4, because the absolute value of 4 is 4. On the number line, 4 is 4 spaces away from 0. 1, 2, 3, 4. Another possible answer would be negative 4. The absolute value of negative 4 is also 4, because on the other side, negative 4 is also 1, 2, 3, 4 spaces away from 0. What we're going to see when we're solving absolute value equations are more than one solution. In this case, we have two solutions, positive 4 and negative 4. Now, that was a very simple one to start. What if we were to replace that x in the previous problem with a more complex algebraic expression, something like 3y plus 2. Now, most of our equations up until this point, we've had x as a variable that we're solving for, but sometimes it could be another variable, another letter, like in this case it's y. So we're just going to solve for y. So this equation is, it's saying the same thing. It's saying that this quantity, 3y plus 2, must be 4 spaces away from 0 in either direction. And so immediately we are going to split this into two separate equations to show that 3y plus 2 could be positive 4, so 4 spaces away from 0 to the right. Another possibility is that the value of this quantity, 3y plus 2, is 4 spaces away from 0 in the other direction, to the left, and so we're going to set that equal to negative 4. Notice how we're not using the absolute value symbol anymore when we split it into these two parts. Now we're going to continue solving each equation separately, and that's going to give us two solutions. So here we're going to start by subtracting 2 from both sides. Then we'll go ahead and divide both sides by 3. Our first solution here is 2/3. Just leave it as a fraction. That's good. And we'll do a similar process on this side. Start by subtracting 2 from both sides. And then we'll divide both sides by 3. And the other solution we get is negative 2. Now, just as always, anytime we're solving equations, if you were to plug in the values of the solutions that we got, plug it in for y back in the original equation, you're going to see that it makes that original equation true. Can absolute value ever be negative? Well, if we think about the definition that we said earlier, absolute value measures the distance away from 0, and distance is always positive. So the quick answer to this question is no. And so if we see a quantity like this, the absolute value of something, in this case 5x plus 3, is equal to negative 2, this is an equation that has no solution. The absolute value, the distance away from 0, can never be negative. So be on the lookout for that. Usually I put at least one of those in an assignment for this unit. It could even show up on a quiz or a test. So absolute value can never be negative, simply no solution. All right, next, the next equation. So it's an absolute value equation, but there are a few extra things going on the left side in addition to just the absolute value part. So I'm going to take a moment here to highlight the absolute value of x plus 9. Before we can do the step of splitting it into the two equations like we did earlier, we have to actually deal with this 2 in front, and we have to deal with that plus 3 at the end. And so we need to isolate the absolute value part first, and isolate means that we're going to get it by itself. If you're in isolation, you are all alone. So we're going to start by subtracting 3 from both sides. We're just going to think about the similar steps that we've done in solving equations. And to think about getting rid of the 2, I made a note in this box off to the side. It's very important that we do not distribute the 2 into the absolute value of x plus 9. We are not allowed to do that. The distributive property does not apply to absolute value. It's not the same thing as parentheses. So that 2 is not able to go over that straight line. And so the only way to get rid of it, that 2 is really being multiplied by that absolute value quantity. And so the inverse of multiplication, if we want to undo that, the opposite of multiplication is division. So we're actually going to divide both sides by 2 as a way to get rid of that. So now we've got the absolute value of x plus 9 all by itself, just as we want, and that's equal to 2. So now we know that quantity, x plus 9, this is saying that it's 2 spaces away from 0. So it could be 2 spaces away from 0 on the right, so x plus 9 could be positive 2, or it could be 2 spaces away from 0 to the left, and x plus 9 could equal negative 2. So this is where we're splitting it into the two equations. I think earlier I like to do the little arrows like this, but since I moved to the side, my arrows are looking a little different. But we don't have the absolute value sign anymore in this step. Let's go ahead and subtract 9 from both sides to get our first solution of negative 7. And our second solution, negative 2 minus 9, is negative 11. So these are our two final answers. We have one final absolute value equation. This one has a little bit more going on with it. Notice that on the left side, the absolute value part is already isolated. So unlike the last problem, we don't need to do additional steps to get it by itself. It's all ready to go. But what I want you to notice is that on the other side, it's no longer just equal to a number. It's equal to an expression, 7x plus 14. So we actually have an additional x showing up over here on this right-hand side. Well, the way we're going to approach this is actually no different to what we were doing above. The steps, the process is going to look a little different, but it is the same idea of taking this absolute value, what we have on the left side, splitting it into two equations so that we're able to rewrite it without the absolute value. So let's think about this first equation. I'm going to start by writing 5x minus 2, no absolute value needed here. And this 7x plus 14, so even though we don't know what x is yet, this side represents a number. Eventually when we solve for x, we'll know what that number is. But just think of it as a number. Even though it looks like algebra right now, it looks like an expression, think of it as if it was a number, like 10 or 15, just regular numbers. So normally when we solve absolute value equation, our first equation, we set it equal to the positive version of the number on the right-hand side. Well, the positive version of the number, we're just gonna recopy it down, 7x plus 14. So that would be like, if it was a 10, that would be like positive 10. That's the positive version of that number. Now for our second equation, we still have 5x minus 2 for the first part. Now we're going to set that equal to the negative version of whatever that number is. So all we're going to do is put a negative sign in front of the quantity 7x plus 14, but we're putting the 7x plus 14 in parentheses because that negative sign is actually going to distribute to both parts. So really it's negative 7x minus 14. So that's how we do the negative version of that number. So now we still have two regular equations that we're going to solve separately to get two possible answers. So let's go back and look at our first equation. Because we have x showing up on both sides, we're going to continue by moving the variables so we have all the variables together on the same side. So on the left, 5x minus 5x, that goes away. Bring down the negative 2. 7x minus 5x is 2x. Bring down the plus 14. Now we're going to get the 2x by itself. We'll do that by getting rid of the plus 14, thinking about inverse operations. So we're going to subtract 14. The 14 minus 14 is going to go to 0. Negative 2 minus 14, we have negative 16. Bring down the 2x. Now we'll go ahead and divide both sides by 2. And our first possible solution is negative 8. All right, similar set of steps on the other side. I'm going to start actually the very same way, subtracting 5x from both sides. This time we have negative 7x minus 5x, so that's negative 12x. Now this time, because it's a minus 14 here, I'm going to add 14 to both sides. So minus 14 plus 14, that will cancel, leaving me with negative 12x on the right. On the other side, negative 2 plus 14 is positive 12. We'll go ahead and divide both sides by negative 12. And we get our second possible solution of negative 1. Now you may have noticed this time around I said these are possible solutions. Another thing you may have noticed in the directions that I did not mention earlier is that the problem tells us to check for extraneous solutions. An extraneous solution sometimes occurs in algebra. It's a solution that is a result of doing the algebraic steps, but it does not actually make the equation true. So it's not actually a real solution. We're going to have to throw it out. And the way that we're going to determine if we have an extraneous solution or not is to simply check by plugging the answers that we got into the original equation and see if it actually makes the equation true. So it's really important that we plug it back in to the original version that involves the absolute value sign. So we're going to plug it in here. If you plug it into like this version right here or that version, it will be true 100% of the time because that's where the answer came from, was from solving that. We need to take it a step higher and make sure that the absolute value sign is in there. So I'm going to walk through the steps showing how we can check our first solution of negative 8. So notice how I'm replacing x with negative 8 on both sides. And when I'm checking my solutions, rather than just writing an equal sign, I like to write a question mark above my equal sign because that reminds me that, hey, I'm not stating that the two sides are equal yet. I'm checking to see if they are equal. So on the left side, 5 times negative 8, negative 40, and then we're going to subtract 2. So that's going to be the absolute value of negative 42. Remember from earlier, we know that absolute value makes numbers positive. So the absolute value of negative 42 is just asking how many spaces that number is away from 0. It's 42 spaces away. So the result on the left side is actually positive 42. Let's do some work on the other side. 7 times negative 8 is negative 56. If we add 14 to that, we get negative 42. So notice how the left and the right side are not the same. It's not a true statement. I'm going to draw a little sad face here. So negative 8 doesn't actually work. It's not actually a solution, so we're going to do a big X through it. It's called an extraneous solution. Let's do a similar process here to check the solution of negative 1. So we'll start by plugging negative 1 in for X. Here's my little question mark because we're checking to see if the two sides are equal. So 5 times negative 1, we get negative 5. Negative 5 minus 2 is negative 7. And the absolute value of negative 7 is positive 7. Let's see the result on the other side. We get negative 7 plus 14. And sure enough, if we add those together, we get positive 7. So this one did work. I'm going to put a smiley face here. So this is our one and only solution that worked. All right, one final thing I'd like you to do. So underneath this last example, if you have some space at the bottom, I would like you to write your birthday. So just write the month and the day. You don't have to write the year. The month and the day of your birthday. All right, thanks for listening. That's how you solve absolute value equations.